All right, good morning, Algebra 2 class. We've just solved systems of equations, and solving systems of equations was so easy and so much fun that I'd like to throw something very, very long and drawn out at you, and we're going to call it solving systems of equations with three variables. And the only difference is we have another variable that we have to worry about. Before it was two variables and we could just look at it, eliminate one or substitute, and then solve for the other, plug it back in, and then we were pretty much done. We could find a solution real quick. This one has a system of equations, and it's got three different variables. So you have three equations with three variables. And I'm going to show you what that looks like real fast. Here's our example. Our example is right here. Now this one is set up simply so we could do some elimination and yada, 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 but it's three equations with x, y, and z. And what happens is when we're talking about x and y, we're talking about the coordinate plane, right? When we add z, now we're making it three dimensions. And yes, that's all well and good, but right now you can't graph that third dimension because you're only writing on a piece of paper. If we could set it up in a computer with 3D animation, we could go ahead and graph that and turn it and then show that these planes all connect, but it's, you know, there's one more plane that's sticking out this way. Anyway, these are our three equations. I'm going to blow this up a little bit, but I want to be able to tell you what needs to happen. All right? Step one of solving this system of finding a value for x, y, and z is to use elimination to take these three equations and eliminate one of the variables and make it two variable equations. So I'm gonna take these first two and I'm gonna solve it down to two variables. And then I'm gonna take the next two and solve this down, eliminating the same variable and knock it down to two variable equations. And here's how they did it. They took the first equation. I'm going to blow this up a little bit so you can see it a little better. Yeah, that's better. Good deal. All right, let me get rid of this. Pardon me. Let me go ahead and jump down here. Whoopsie. There we go. Here it is. Okay, so they have this first equation, 3x plus y minus z equals negative 6. And then we're going to add to it 2x minus y plus 2z equals 8. All right, if we add 3x plus 2x is 5x, y plus negative y, that y disappears, and negative z and positive 2z give me just 1z. So we have knocked it down to one of the two that we need. We have two variables and we're good. So they took the second two equations, the one in the middle that we already used, and added the third one. Okay, so 2x plus 4x is 6x, negative y plus y, nope, and then 2z minus 3z is negative z. Now we're set 8, negative 21, negative 13. Now, that's our second equation. We've eliminated the y altogether. Now, we take the two equations that we've just created, that's what they've done, and we say, hey, this is really set up for us. We can go ahead and solve, we can eliminate the z and then solve for x. This is really good for us. And so we add these two together. 5x plus 6x is 11x. Plus z minus z gives me no z's there. 2 minus 13, or 2 plus negative 13 is negative 11. 11x is negative 11. X has to equal negative 1. Well, now that I know that x is negative 1, I'm going to plug negative 1 back into this equation here. And there we go. Here it is. We plugged the negative 1 back in. So 5 times negative 1 is negative 5 plus z equals 2. Now we add the 5 to both sides, and z equals 7. Great. Now we have x and we have z. Now all we have to do is plug the values we found for x and z into one of the original equations. And I believe, if I'm not mistaken, they plug it into the first equation. Negative 1 is our x, 7 is our z. We've plugged them in, we've done the math, and y equals 4. So x is negative 1, z is 7, and y is 4. Now, you're saying to me, Mr. Sokol, this is ridiculous. It's a very long process. I say to you, yes, it's a very long process. And sometimes, just sometimes, it's not going to be set up as beautifully as that one was. Sometimes you're going to have to multiply to get to a place where you can eliminate. And hopefully, one of these on the bottom, I can show you where you'll have to multiply. Yeah, let's do either one. All right, so let me blow this up. Make it real big. All right, what I need to do is I need to eliminate an x, a y, or a z. None of these are opposites of each other. So my first thing that I have to do is that I have to scale something up by some sort of factor so that I can eliminate one of the variables. And that was what we were doing before with our systems, but now we're going to make this process even longer. And it takes like a whole page of paper to get through one system. And then I give you a page of 6 systems, and you look at me like, sir, I don't have enough paper. Anyway, let's try one together. Let's look. 2x plus 3y, you see all these. Just for fun, let's eliminate x. Okay, we can do that. We can decide on our own. Let's eliminate x. We could have eliminated y or z. I say let's eliminate x. Well, if I'm going to put the first two together and then the second two together to eliminate x, here we go. I have a 2x and I have an x. If I multiply this whole equation by negative 2 and rewrite it, then I will have an equation that I can solve. I can then do my addition. So I'm just going to do it right here. Negative 2. Negative 2. All right? So when I rewrite this, it's negative 2 times x, or negative 2x. Negative 2 times negative 2 is positive 4y. And then negative 2 times negative 4 is positive 8z. Okay? If I did it on this side, I have to do it on the other side. So 14 times negative 2 is negative 28. Okay, well now I have these two equations and I've factored this up so that I have opposites so that I can add these two. So here we go. Are you scared? Of course you're not scared. I'm going to rewrite real fast. 3y minus z equals 0. Negative 2x plus 4y plus 8z equals negative 28. Let's add them together. We're going to add them together. We're going to get our first two variable equation, these two things get eliminated. 3 plus 4 is 7y. Negative z and positive 8 is positive 7z. And 0 plus negative 28 is negative 28. Now, if I need to, I can factor this down later. But I'm going to take this. I'm going to rewrite it up here. This is one of our... Oops. So y. 7y plus 7z equals negative 28. That's one of our equations that we're going to use for step 3. Here we go. All right. I'm going to undo this, take it back to its regular problem. All right. I have x and I have 3x. I want the opposite of that, right? So I'm going to multiply everything by negative 3 all the way across, each piece of this puzzle by negative 3. X times negative 3 is negative 3x. Negative 2 times negative 3 is positive 6y. Negative 4 times negative 3 is positive 12z. And then 14 times negative 3 is positive, what is that, 42. Sorry, it's negative. I lied to you. Please forgive me for lying to you. All right, well, these are all set. And I'm not going to move it and rewrite it. I'm just going to go ahead and do the addition since they're sitting right on top of one another already. All right? Negative 3x and 3x gives me no x's. I've eliminated it. 6y plus 1y is 7y. Uh-oh. 12z plus negative 8z is positive 4z's. And then, what do we got? Negative 25, right? Did I do that right? Yeah, I think I did. All right, so now I have my second one. So rewrite over here my second two-variable. Oh, look at that. Set up beautifully. Are you ready? I can now solve by eliminating my y or my z. Well, it looks like I have 7y and 7y, so I think I'm going to go ahead and eliminate my y's. And what I'm going to do is I'm going to multiply everything by negative 1 just because I don't want you playing with subtraction. If I multiply every piece by negative 1, now I have opposites with my 7y's. All right, I know this is taking a long time, but hey, stick with me. We are really, really close to being finished. So I can eliminate the y. 7y plus negative 7y gives me no y's. 7z plus negative 4z is 3z's. Wow, look at how wonderful this sets us up. All right, negative 28 and positive 25 is negative 3. So z is equal to negative 1. All right, there's one of my variables. I take that negative 1 and I plug it back in to this first of the two variable equations and solve. So, here we go. Are you scared yet? I'm going to rewrite that one. 7y plus, pardon me, 7 times negative 1 equals negative 28. All right, well, I can do some math now, right? I have 7y minus 7 equals negative 28. I add 7 to both sides. That leaves me with 7y equals negative 21. So y must equal negative 3. Oh, great. Now I'm really set. I have a z and I have a y. And I just need to solve for the last variable. What I'm going to do is go back to my first original equation. The one way back up here. I could use any of these three, but just for my purposes here, I'm going to use the first one. And I'm going to write it out and solve for x. 2 times x plus 3 times negative 3 minus negative 1 equals 0. So far, so good. I can do this math. So I have 2x minus 9, because 3 times negative 3 is negative 9. And then minus a negative is plus a positive, right? Equals 0. We put these together, we get negative 8, right? 2x minus 8 equals 0. We add 8 to both sides, so 2x equals 8, therefore x equals 4. And if we want to write it as coordinates on our three-dimensional plane, we're going to say x is 4, y is negative 3, and z is negative 1. It was a long, arduous process that you went ahead and took care of, but it can be done. Don't forget that you can scale up equations so that you can eliminate, okay? Multiply them by a factor. That's it. I know it was almost 18 minutes of this, but it's very, very important to get used to a very long process. That's what life is all about.